What's up, friends? Let me get over here and say hello to you all. Welcome back to our first lab investigation since before Thanksgiving break. So, hopefully this works. I've already recorded this once, only to find out it stopped recording 2 minutes and 39 seconds into it. And then I tried again, and then it said my mic stopped working for some reason, so I'm using a different setup on the mic. I think it's coming from the computer instead of the webcam. Now, whatever's happening, hopefully it works, so we're going to find out. Now, here we are. It is officially December for you guys. I'm filming this on November the 30th, so I'm filming this in the past. But it's the holiday season, man. Happy December to everybody. Even Grumpy's happy. He's up here to help out today, so now that Grumpy's hanging out, we can all be happy. So, we have an experiment that we're going to be doing today. This experiment is going to involve a cup, some bags of cereal, and is going to model how sedimentary rock is formed. Remember, we talked about yesterday how it gets deposited in layers. So sedimentary rock will be getting formed, but we're throwing in a little bit extra. We're throwing in some stuff that's modeling organic material. Organic material comes from organisms. There's a root word in there, organ. For organisms are living things or once living things. Organic material comes from living things. So when organic material gets left behind in large amounts and gets buried and put underneath all of the pressure and the heat and everything like that from other sediment layers getting deposited on top, then you have a good chance of it turning into fossil fuels. That's where we get our coal, our oil, our natural gas from, is from dead organic material that over millions of years, we're not talking a few hundred years, we're talking millions of years, this organic material is turned into fossil fuels, and now we burn that to release the energy and use it for various things, to heat our homes, to drive our cars, and all those other types of things that we use coal or natural gas or oil for, okay? So, let's look at our materials, let's look at what we're going over, and then we'll get rolling. So we have 4 bags. We've got bran flakes. We've got Cheerios. We have Fruity Pebbles. And we have a mixture of coffee, ground up coffee, and Cocoa Krispies. You guys are probably like, ooh, I like the Cocoa Krispies, but Mr. Knox, take that ground coffee out. It smells kind of weird too. I love the smell of coffee, but not necessarily coffee with Cocoa Krispies. We also have our instructions right there, which will be available for you guys in the module. And I have a copy up here that I'll go through while I do it. And then we also have our lab reports. Looks like this, which will be in a different video. I will fill this out to show you guys what goes on with that. Okay, so again, if you cannot print this, you will be writing it down in your science notebook, in your ISN, your interactive science notebook. And I will show you how to do that as well. Okay, so with all that being said, let's get started and hope this works. All right. Flip it over to part 1. Part 1, laying the foundation. The formation of coal. It says right here at the top, the formation of coal. So that's what we're looking for with this one. Now, it says take the bag labeled Cocoa Krispies and coffee. All right, and it's got to be mashed up a little bit. And we're going to pour the contents into one of the plastic cups. So here's our plastic cup. Yeah. Kind of gnarly, man. It's pretty gross. But it actually smells kind of good because of the coffee. I like my coffee. Alright, so that's good enough. I don't have to get all perfectly out. So I've got a little layer here of organic material. Because I know what this is. This layer of your cup represents an ancient swamp that existed 300 million years ago. That's a long time ago, friends. 300 million years ago. And the Cocoa Krispies and coffee represent ferns and other swamp plants. So ferns and other swamp plants. Are plants living? Mm-hmm. If they're dead, were they once living? Uh-huh. So does that make them organisms? Yup. So does that mean they leave behind organic material? It sure does. Okay? I'm also going to throw in, just, to spice it up a little bit. A little bit of salt to represent some animal bones. Right? Because it's not always just plants that are the organic material, but sometimes animals too. Now, here we go. We've got our layer of ancient swamp material, 300 million years ago. Now, that word ancient is important. That means very, very old. We're not talking about Mr. Knox is ancient. I might feel it some days, but I'm not millions of years old, okay? So 300 million years ago, that's when we're starting. So our timeline way back here, 300 million years ago. Next, formation of sandstone. Crush the Fruit Loops, it says. We have Fruity Pebbles instead of Fruit Loops, so still colorful. We're going to crush them up. Woo. This is when I need one of those fancy microphones with the little ears on the side, right? The little binaural microphones. Have a little ASMR sound effect session. All right, here we go. But we're not doing that. So, we're going to pour the crushed Fruit Loops over the Cocoa Krispies and coffee mixture. All right? And then we'll read about what this represents. So there go our Fruit Loops. That's a big layer of Fruit Loops. Or, well, Fruity Pebbles. All right, so let's see. The crushed Fruity Pebbles represent the sand that was carried by a river which then covered the ancient swamp area. It took millions of years for this layer of sand sediment to build up. So we have our organic material down here on the bottom. We have our sand here on top. The sand came from a river. So remember, water shapes land, and we'll be talking more about that as we move through things. But so we've got a river that has now flowed and found its way to the swamp. And this river is bringing water into the swamp, but it's also bringing in sediment. So it's carrying sand with it, and as it gets to this swamp, it slows down and it deposits and it drops the sand down. So that the sand then covers up all of those dead plants. So think about a swamp, right? It's covered in some water, not super deep water, but some water. And as those plants kind of die on the bottom, you can just kind of picture all that ooey, gooey, mushy, swampy, just gunk on the bottom, right? Okay, well that's all of like the dead grasses and ferns and trees and stuff that fall down and all the plants. And so all of that layer is there, but then the river brings in sand to kind of cover it up, right? So that happens over millions of years. And so over millions of years, that sand builds up and makes a bigger layer. Layer 3, the formation of shale. Crush the bran flakes from the fine pieces and pour them over the sandstone layer, which is our Fruity Pebbles. Then we'll read about the backstory for this layer and find out how it became a thing. How did you come into existence, layer of shale? Woo! And spilling it. That's why I have a tray, so it doesn't end up all over the floor. Okay. So, let's see. The swamp area began filling with water after the sand layer built up over the dead ferns and other swamp plants of the ancient swamp. So as that sand layer builds up, right, it's going to make it harder for that river to keep flowing. So it builds up over time with the sand layer, and it says the crushed bran flakes represent the fine clay-like pieces that fell to the bottom of a newly formed lake. So a lake ends up, so the river still keeps flowing, but it stops flowing through the swamp. It kind of stops, and then it fills up as a big lake. So in that lake, you end up with more sediment that gets deposited, and this is clay-like sediment, which is another type of dirt or soil. We have a lot of clay in this area of Texas because this used to be a shallow sea, so we had lots of that type of material deposited here. So a lot of our soil is actually clay soil. Anywho, so the crushed bran flakes represent the fine clay-like pieces that fell to the bottom of the newly formed lake. The fine clay sediments built up on the lake bottom more than 65 million years ago. So we're still in ancient times, right? So we are sitting here 300 million years ago, and 235 million years have passed. We are now 65 million years ago, and we have a couple more layers. So we're looking at our organic material, we're looking at our Fruity Pebbles, which is our sand, and now we're looking at our clay, which dropped from the lake. And then our last layer here. Ooh, I'm going to get someone to help crush this up a little faster, or at least better. My coffee mug. All right, coffee mug. So this here, it says the lake dried up. Sand was blown and deposited into the area by wind. So eventually that lake dried up, but there's still obviously wind, there's still sand around, and so what happens is that wind blows the sand in. I'm assuming you can hear me over this crunching noise. And the sand gets blown in and covers up the sediment that was left at the bottom of the lake that dried up. Okay? So here comes the wind. Sound effects. More wind coming. And then, woo! The wind deposits or drops this sand. Guys, if you've been to the beach, you know the sand gets blown around by wind. If you've seen videos of a desert, you know the sand gets blown around by wind. But the wind doesn't blow forever. It eventually runs out of energy. So while it's eroding it and taking it away, it also drops it and deposits it elsewhere. So now we have our fourth layer. So it says that this layer here is also going to turn into sandstone. So we have our layer of organic material, the ancient swamp plants, with a little bit of bones from animals sprinkled in. We have our layer of sand that came from the river that washed in and deposited the sand on top of the organic material. We have our layer of clay that got deposited. I don't know how well these are showing up in here. Kind of, they got deposited in the from the lake, so it got deposited over top of the sand. And then we have the sand that got blown in from the wind after the lake dried up over millions and millions of years. Now, we have to add heat and pressure. So here it says, press your hands together really hard, right? You can feel pressure, feel a little bit of heat. That kind of models what happens underground, just on a much bigger scale, right? So it says, we're going to take our other cup. This is the one that I had already done when it stopped recording, right? And so we're going to take this cup and we're going to crush down. We're going to model this. Now, I can't do it as well because I can't get my hand all the way in there because of all this other stuff. But we're going to crush it down. And this is modeling the pressure from all of those layers that get deposited on top. And then gravity obviously pulling them down, right? Towards the center of the earth. And that pressure ends up compacting the layers and squeezing them down to where you end up with layers of what turn into sedimentary rock. Unless it's organic material from something that was once living, like these ancient plants from the swamp, then it's going to turn into fossil fuels. Okay? And so in this case, these are turning into coal. We have then sandstone, then shale, which is another type of sedimentary rock, and then more sandstone, which is also sedimentary rock. So, all right, that is going to be that part of the lab. It still says it's recording, so hopefully we've made it to the end. Remember, big idea here is that the sedimentary rock gets deposited in layers, or sediment gets deposited in layers to form the sedimentary rock, right? But if it's a layer of organic material, it's going to turn into fossil fuels instead. It happens the same way the sedimentary rock forms, just instead of being made up of sand or other things that are not organic, like tiny little bits of rock and stuff like that. If it's made up of organic things from plants and animals, then it's going to turn into fossil fuels instead of sedimentary rock, okay? All right, over millions of years, not quickly. So let's go ahead and move on to our next video where we're going to look at our results and we'll kind of reflect on everything, okay? Cool, see you soon. Bye.